All right, so today we're going to be looking at lesson 15.4. We're going to be continuing our lesson on different types of quadrilaterals. The lesson that we just looked at was dealing with parallelograms, and we are going to be now looking at some specific types of parallelograms, which is the rectangle, the rhombus, and the square. So starting with the rectangle, it is a parallelogram, which means it has two pairs of parallel sides, and it has to have 4 right angles. So if you know you have a parallelogram with 4 right angles, that is actually a rectangle. So they give us a quadrilateral, and they tell us it's a rectangle, and we want to list all of the right triangles in the figure. So one of them is this triangle right here, triangle RTC. Another one is this triangle here, triangle ECT. Another right triangle is triangle CER. And then the last one is this one right here, which is triangle TRE. So those are your 4 right triangles, and they want to know how you know that they are congruent. Well, we know they all have a right angle, so they're all right triangles. We also know, if you look, they share these sides and these sides, and so those are some of your side lengths. You could also say that they share the diagonals if you wanted. They all have those diagonals in common. And then pick one of the side lengths. And so you could say that they're congruent by hypotenuse leg, or you could say by side angle side. Either one of those would work. So then this next one is about a theorem. The diagonals of a rectangle are going to be congruent. And the reason that we know they are congruent, the diagonals are the corresponding parts in those congruent triangles. So shorthand, you could just say CPCTC. Since we have congruent triangles, all those parts have to be congruent. And that's what CPCTC stands for. So now we're going to go through and list the properties of a rectangle. There are a bunch of them. One of them is the opposite sides are congruent. Another one is that the opposite sides are parallel. Another one, your diagonals bisect each other. Another one, the theorem that we just looked at, the diagonals are congruent. Another one is dealing with the angles. All the angles are congruent. Also, all the angles are 90 degrees. So those are some of the properties of a rectangle. Now we're going to look at number 5. Given the quadrilateral PINK, that's a rectangle, and then they give us coordinates for P, I, and N, we want to find K. So one of the easiest ways to do this is to graph your points that they give you. So if you start by graphing P at 3, 0, I at 0, 6, and then N at 8, 10. This is part of our rectangle. We know it's PINK, so we know that P and I have to connect and then to N because of the order of the letters. So K is going to be somewhere in this general area. We don't know exactly where, That's what we're trying to figure out. But we can tell that's kind of where our fourth vertex is going to be. So one way to do this is just to look at your slope from I to N. If you count your slope from I to N, you're going to go up 4 and to the right 8, which will reduce, but we don't want to reduce it. We want to leave it as that. So we're going to look at P and do the same slope. So we're going to go up 4 and then go to the right 8. And that point right there is where K would be. And so then if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4. You end up at 11, 4 for K. So that's one way that you can do that one. There are other ways. I personally think the graph is the easiest option for that one. So now let's look at number 6. They give us a quadrilateral that's a rectangle, and we want to use the properties of a rectangle to answer the following questions. So if it is a rectangle, we know that the diagonals are both congruent and they bisect each other. So what that means is that each of these 4 parts would have to be congruent. So Tx and Fx and Gx and Ix are all congruent because those are the 4 parts of your diagonals. So if you look at A, it tells you Tx is 13. So that means that each of those 4 have to be 13. So then Ti is 2 of those parts. So if you double it, you end up with 26 because each of these were 13. Then the diagonals are congruent. So the other diagonal should also be 26. For part B, not using those same numbers, still using the same figure. It tells us Tx and Fx. We know those are parts of our diagonals, so they have to be congruent. So I can say 7x minus 23 equals 4x plus 4. And then I can solve that for x. So subtract 4, 3x minus 23. Then if you add the 23, you'll have 27. And so then divide by 3, x would be 9. For part C, they give us angle information. So angle XFT. This is angle XFT. Since this triangle here is an isosceles triangle because these 2 sides are congruent, I know that this angle is going to be congruent to this angle. So I'm going to erase it so that I don't have quite so many markings. These 2 angles are congruent. The other angle they give me is angle XTG, which is this angle. If you look, these 2 angles are complementary. They equal 90 degrees, and that's because we have a rectangle and all of our angles are right angles. So the 2 angles that they give me have to sum to equal 90. So the equation that I could set up here, 6x minus 4 plus 10x minus 2 equals 90. If you combine your like terms, 16x minus 6 equals 90. If you add 6 to the 90, you get 96, and then when you divide by 16, your x value is 6. So that's looking at the rectangle. On the next page, they talk about indirect proofs. And for this class, we are not going to go over what an indirect proof is and how to use it. But if you're interested in it, there is one example about an indirect proof. We are going to look down here at number 8 and 9. What do rectangles, trapezoids, and kites have in common, and how do they differ? So there are several things that they have in common. One of them is that they're all quadrilaterals. That's the most basic thing they all have in common. They have 4 sides. How are they different? Well, parallelogram has 2 pairs of parallel sides, and that's what a rectangle is. It's a type of parallelogram. So a rectangle has 2 pairs of parallel sides because it's a parallelogram. A trapezoid is not a parallelogram. It only has 1 pair of parallel sides. And a kite does not have any pairs of parallel sides. So that's one thing you could say. You could say something about the sides being congruent. In a rectangle, opposite sides are congruent. Opposite pairs of sides are congruent. In a trapezoid, none of the sides have to be congruent, but you could have one pair of congruent sides. In a kite, you have to have two pairs of consecutive sides that are congruent, but not congruent to each other. So there are different things that you could say there. Looking at number 9, we want to tell if these are true or false. All rectangles are parallelograms. That is true. If it is a rectangle, it is also a parallelogram because a rectangle is a type of parallelogram. Some rectangles are trapezoids. That is false. So true, false. The reason, rectangles have two pairs of parallel sides because they're a type of parallelogram. Trapezoids only have one pair of parallel sides. So there's no way for them to be the same figure. All parallelograms are rectangles. That's false. A parallelogram could be a rectangle, but it doesn't have to be. So not all of them are going to be rectangles. All rectangles are quadrilaterals? Yes, that is true. All of them are absolutely, for sure, going to be a quadrilateral. So now, let's look at the next page, dealing with rhombus. So rhombus is a type of parallelogram with 4 congruent sides. So if you have 4 congruent sides, that's when you have a rhombus. So they give us this quadrilateral, and we first want to start by graphing the points they give us. So here's our quadrilateral, and we want to verify that the quadrilateral is a parallelogram by finding the slope of each side. So if you look, the slope from U to S, you're going to rise 4 and then go to the right 3. So the slope of US is 4 over 3. If you look at the side that is opposite it, CM, the slope for it, you go up 4 to the right 3. So the slope of CM is also 4 over 3, which means that US is parallel to CM. From there, we need to look at the other two sides. The slope of SM your rise is 0, and then you run 5. 0 divided by 5 is 0. So the slope of SM is 0. The slope of UC is also 0. So that means that SM is parallel to UC. And so we know that it's a parallelogram because it has 2 pairs of parallel sides. Now we want to verify that it is a rhombus. So to find out if it's a rhombus, we need to look at the side lengths. So the two that are going to be the quickest are SM and UC because you can just count. And if you count those side lengths are both 5. So SM equals 5 and UC equals 5. Now for CM, this side length is 3 and this side length is 4. So we can use Pythagorean theorem to find our hypotenuse. So 3 squared plus 4 squared equals hypotenuse squared. A squared plus B squared equals C squared. 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. And so then you take the square root of 25 and you get 5. So that means that the length of CM is 5. From here, we can look at US. This side length is 3 and this side length is 4. And then we're looking for the hypotenuse. If you notice, we just did one with a 3 and a 4. And so that means that our C on that little triangle is also going to be 5. So that means that the length of US is 5. So all of our sides are congruent. They're all 5. So that means that yes, it is a rhombus. All sides are equal. Now we're going to look at the slopes of the diagonals. So the slope from U to M, you're going to go up 4 and then to the right 8. So the slope of MU, 4 over 8 reduces to 1 over 2. For the slope of side or diagonal SC, we're going to go up 4 and to the left 2. So the slope of SC, 4 and then left is negative. 4 over negative 2 is negative 2. And those slopes aren't the same, which they're not supposed to be. And that's what they're trying to get you to see in part D. How are those slopes related? How are negative 2 and 1/2 related? Those are negative reciprocals, and so the diagonals of a rhombus are going to be perpendicular. That's what they were trying to get you to understand with that work. So hopefully that makes a little bit of sense. That's how you can verify that you do have a rhombus. All right, so now let's look at this rhombus that they give us. They tell us that we have this quadrilateral and it is a rhombus, and we want to list 3 triangles that are congruent to triangle HXE. So that's the top left triangle. X has 4 right angles that are about it. All of these angles in the middle are right angles because the diagonals are perpendicular. That's what we just said. So X is what is in the middle here, and so that's what we need to put in the middle of all of the other 3 triangles that we're going to list. And so we said HXE. We could say FXE would be 1 triangle. Another one that you could say would be HXG. And another one that you could say would be FXG. And some of you may want to know, does the order of that matter? Could I say EXF? You could, because these triangles are actually all 4 congruent. And so the only thing that is a must is that the X has to be in the middle, because that's the right angle, and they started with the right angle in the middle. So now, part B asks us to explain why these angles are congruent. So, angle EFX and angle GFX are these 2 angles, and angle HGX and angle FGX are these 2 angles. And the reasoning that those are congruent is CPCTC. We have triangles that are congruent, and those are the corresponding parts. And so if our triangles are congruent, the corresponding parts are also congruent. And so something to notice, these angles here are going to be congruent to these 2 angles. And these angles here are congruent to these 2 angles. And so that leads us into this next theorem. Each diagonal of a rhombus bisects opposite angles. So each of your diagonal bisects the opposite angles. And if you are interested in the formal proof, that is part of your exercise with number 11 on page 222, if you would like to do that. So now let's look at number 12. We want to list all of the properties of a rhombus. And it says, starting with the fact that we know it's a parallelogram. So that means that we know opposite sides are parallel. We also know opposite angles are congruent. We also know that the diagonals bisect each other. And we know that the diagonals are perpendicular. And we know that diagonals bisect opposite angles. And we know that consecutive angles are supplementary. And we also know that all sides are congruent. That's part of it being a rhombus. And the last thing that we know is that a diagonal divides the rhombus into two congruent triangles. And that's what the rectangle does. Specifically, you could even say that the diagonals divide the rhombus into four congruent triangles if you wanted to take that a step further. So you could word that one that way as well. So now let's look on the next page. They give us a rhombus. And we want to use the properties of a rhombus to answer A, B, and C. So first off, they give us angle UPT. Angle UPT is this angle here. We know that the diagonals of a rhombus are perpendicular. So that means that angle is actually a right angle. So we can say 4x plus 18 equals 90. Because it's a right angle, it has to equal 90. So 4x equals 72, divide by 4, x equals 18. For part B, it tells us UT, TA, HA, and UH. Those are your sides for your rhombus, and we know that a rhombus has four congruent sides. So all of these four are equal to each other. So you're going to pick two and set them equal to each other. There are several different ways you could do this. The easiest option is going to be to pick 24 and another equation that only has one variable. So the first and the third one have only one variable. You can absolutely use the 2x plus y. It's just going to require a little bit more algebra. So 5x plus 4 equals 24. Subtract 4, and you have 5x equals 20. Divide by 5, x equals 4. For the next one, 2y minus 8 equals 24. Add 8, you have 32. Divide by 2, and you get 16. So that would be your x and your y values. For part C, PAH is this angle here. PAT is this angle here. Those two angles are congruent because this diagonal bisects those two angles. So 8x plus 2 equals 10x minus 10. So I can subtract 8x to make 2x and add 10 to make 12. And then divide by 2, x would be 6. So now we're going to look at a square. So a square is a type of parallelogram that has 4 right angles and 4 congruent sides. So what that means, a square is a rectangle with 4 congruent sides. A square is a rhombus with 4 congruent angles. A square is a rhombus and a rectangle put together. So looking at number 15, we want to list all of the properties of a square. And there were a bunch of them. So opposite sides are parallel. All of the pairs of angles are supplementary. So these two are supplementary. These two are supplementary. Your consecutive angles are supplementary, but also the opposite angles are supplementary because they're all 90 degrees. So any pair of angles that you pick, 90 and 90, are always going to equal 180. A diagonal divides the square into two congruent triangles. You could also say the diagonals divide the square into four congruent triangles. Same way with the rhombus. Another one, all sides are congruent. Another one, all angles are congruent. Another one, all of your angles are 90 degrees. The rest of them relate specifically to the diagonals. So the diagonals bisect each other. Also, the diagonals are perpendicular. Also, the diagonals are congruent. And the diagonals bisect opposite angles. So those are your properties for a square. It's a rhombus and a rectangle put together. So now they give this Venn diagram. And so they want you to match each of the terms with each of the letters in the Venn diagram. So looking at the terms, the one that is the most general, the most broad out of these, not parallelogram, not quadrilaterals, but polygons. So polygons is the overarching theme that we've looked at. We've looked at specific types of polygons this week, and those are the quadrilaterals. From there, we had three subsections. We first looked at kites, and there was nothing else that was related to those. They had no pairs of parallel sides. From there, we went to trapezoids. And a subset of trapezoids is the isosceles trapezoids. And so that would be C and D. And then 2 lessons ago, we looked at parallelograms. So that's going to be part E. And the types of parallelograms, you have rhombus, rectangle, and square. Square is H. And then rhombus you can put as F or G. And rectangle you would put as the other one, because they overlap to make the square. So, some people say rhombi, some people say rhombuses. Doesn't really matter. It's the same figure. But that's what they were looking at with the Venn diagram. The other option is to look at a picture of them, and I'm going to show that in just a second. So as you can see, these are your types of quadrilaterals. We have, first off, just a quadrilateral in general, 4-sided figure. Then we look at, some books have the term trapezium. Our book didn't really talk about it, but that's just a 4-sided figure where you know specifically that you have no sides parallel, which what we looked at was the kite. No sides were parallel. Then, on the other side is the trapezoid. You have one pair of parallel sides. And a type of trapezoid was the isosceles trapezoid. From there, we went to the parallelogram, which had 2 pairs of parallel sides. And then we looked at the rectangle and the rhombus. Those are types of parallelograms. And if it's both a rectangle and a rhombus, that's when it becomes a square. So that's one way to kind of think through it, if you're looking for a visual to see how they relate. So now we go to this chart, and they want you to look at the properties for each to know what should be marked. So, starting with the 4-sided figure. A quadrilateral is a 4-sided figure. A kite is a 4-sided figure, so is a trapezoid, a parallelogram, rectangle, rhombus, square. They all have 4 sides. For opposite sides parallel. Quadrilateral? No. Kite? No. Trapezoid? No. It has only one pair, and this is meaning two pairs. But parallelogram, rectangle, rhombus, and square all do. Opposite sides congruent. Not a quadrilateral, not a kite, not a trapezoid. That is a parallelogram, rectangle, rhombus, square. Opposite angles congruent. Not a quadrilateral, a kite, or a trapezoid, but parallelogram, rectangle, rhombus, square. The diagonals bisect each other. That would, again, be parallelogram, rectangle, rhombus, square. Are you noticing a pattern? If the parallelogram works, then the other ones below it are also working because they're types of parallelograms. Consecutive angle supplementary, that's a parallelogram, a rectangle, a rhombus, and a square. For the diagonals being perpendicular, a kite has that property, as does a rhombus and a square. Looking at 4 right angles, that's only the rectangle and the square. 4 congruent sides, that's only the rhombus and the square. And so the last one is exactly one pair of opposite sides that are parallel, and that is the trapezoid. So that's the properties that they were hoping you would get out of that. Now let's look at number 18. Tell whether each statement is true or false. All squares are rectangle. That's true. All rhombuses are squares. That is false. All squares are parallelograms. True. Some squares are kites. No. Squares have 2 pairs of parallel sides. Kites do not have any pairs of parallel sides. That's false. No rhombuses are trapezoids. So, are rhombuses trapezoids? No. And that's what it's saying. So that is a true statement. The way they worded that was a little tricky, but rhombuses and trapezoids are not related. So what do rectangles, squares, and rhombuses all have in common? They're all parallelograms. They're all a type of parallelogram. So now we're going to look at a couple of practice problems. We have a rectangle, and we have diagonals. So we know that all of these diagonal parts are congruent. Since it's a rectangle, we know that our angles are right angles. So if they tell us this angle is 65, I know that this angle here is 25 degrees. Also, this triangle here is an isosceles triangle. So if this angle is 65, this angle is 65 degrees as well. And then if I use the fact that the 3 angles in a triangle add up to equal 180, this angle here would be 50 degrees. Likewise, this triangle up at the top is isosceles. And so if the top right angle is 25, the top left angle is also 25. And then 180 minus 25 leaves 130 for this middle angle. You could also look at the fact that you have parallel lines, and this is a transversal, and so if this angle is 25, this angle here is 25 degrees as well. So let's look at some of the angle measures that they gave us. DAB is a right angle, so it's going to be 90 degrees. ADC is also a right angle, so it's going to be 90 degrees. If you look at BDC, that's this angle here, which is 25 degrees. If you look at angle BDA, that's this angle here, which is 65 degrees. Because remember, these have to be a right angle. Angle AEB is 130. Angle BEC is 50 degrees. And then angle BCE is 65 degrees. So, if you look, these 2 triangles are congruent, and these 2 triangles are congruent. And that's the case in every rectangle. Looking at 21, our diagonals of a rhombus. These are perpendicular. Also, the diagonals of a rhombus bisect the opposite angles. So if this angle is 30, this angle here is 30. Likewise, since our opposite angles are congruent in a parallelogram, these angles are also 30 degrees. Then we know this is a right triangle. And so if we have a 90-degree angle and a 30-degree angle, 180 minus 90 minus 30 gives 60, because your three angles have to add up to 180. So using that information, we know that angle QSR is 60 degrees, angle QST is 60 degrees, angle QTS is also 60 degrees. So the reason that one's 60, QTS is 30 plus 30, which makes 60 degrees. Then angle QZR is 90 degrees, angle QTR is 30 degrees, and angle RZS is 90 degrees. Looking at the last one, a diagonal of a square is 10 millimeters. So we have a square, and we know the diagonal is 10. Since it's a square, we know that we really know all four, but we know that the two sides have to be congruent. And so we can use Pythagorean theorem on this triangle, where our sides are the same thing. So A could be x and B could be x. You could use any variable there, but x squared plus x squared equals 10 squared. X squared plus x squared is 2x squared equals 100. If you divide by 2, you get 50. And so then you can take the square root, and then for 50, it factors as 5 and 10 factors as 5 and 2. So we could write 50 as 5 times 5 times 2. We have a pair of 5s, so if we pull out that pair of 5s, we're left with 5 square roots of 2. And so that's the length of one of your sides. From there, area is base times height. And if you multiply those, 5 times 5 is 25. The square root of 2 times the square root of 2 is the square root of 4, which is just 2. So 25 times 2, 50 millimeters squared. So that'd be your area. So hopefully that helps you some with understanding how your rectangles, rhombuses, and squares work with this lesson.